All right, we're good. We're going.
Okay, great. So I'll present a little tutorial on how one can develop agents in Concordia for Concordia Contest using a specific example. And the angle in this tutorial is sort of a prompt engineering, mostly English approach to agent development. Um, so Concordia Contest, just to set the context of this, is about using kind of language-enabled generative agents in mixed motive situations where they can talk and act and talk really freely about anything they deem necessary. And they'll be put in a variety of situations where to attain high return, this will be games sort of associations with a particular return quantitative outcome there that they must engage in some sort of cooperation. So they, although they're scored on their each own welfare, they best be like to maximize it. They need to somehow coordinate, cooperate, and agree with others on something. It's test skills like promise keeping, negotiation, reciprocity, and so on. Just a historical context of this is, for example, Axelrod contest or ImageNet or Adari. A lot of contests throughout kind of history of ML and game theory provided the ramp for the area. So we would hope for so if out of Axelrod contest tit for tat came out as an algorithm that really was beating everything, we hope for something like that, some sort of a potentially very simple solution to these environments that just works really great. We don't know what it is. We want to find out, and that's the contest. So the overall view of the system and is inspired by role-playing games like Dungeons and Dragons. So the agents, they produce actions and consume observations. They see something about the world and they do something about the world. And then there's a special agent in some sense, a game master that consumes actions and produces observations. And this is where grounding is happening, provides the context of interactions. This is where the rewards are computed, the log of events is happening. While agents, they bring their own individual context and behavior. So the sort of the experiment in Concordia, or a run kind of a game, consists of putting together an agent class, which is an architecture. I'll give a bit more details of what that is, and a simulation class, a substrate. Kind of you put them together, and it kind of on the output you will have a HTML log with simulation and scores. So this tutorial we're talking about agent class. So a Concordia agent is architecture plus memories that put together can produce action, can act. So, and in this way, the agent decision-making progress is sort of has to be designed behind a veil of ignorance to the individual circumstances of an agent. These circumstances are conveyed through memories, and the memories are part of an environment. So when you submit an agent architecture, you're not submitting a specific individual with its dispositions, memories, and facts about it and circumstances. Now you submit a cognitive architecture that will have to have given the memories that in the circumstances that it cannot know about a priori. So
in practice, it has to work regardless of whether
yes.
the agent is nice or mean or whatever.
Yes, nice, mean, whether they're buyer or a seller,
whatever.
Poor or rich, which social role, which identity they assume. You don't know. You will kind of have to figure it out. Like they have to figure it out from the stream of experience. So they don't know who they are. They have to figure it out as they go. So today I'm going to talk about designing agent decision process via a specific metaphor of question of recent memories. So I will first give sort of a conceptual overview of it. So, for example, in political science, and this is a quote from Mark and Olson, The Logic of Appropriateness, a pretty important publication in political science, where they say that humans act by answering three questions. What kind of situation is this? What kind of person am I? And what does a person such as I do in situations such as this? And then they act accordingly. So it's just a model. It's not that this is how things have to be. But how do we implement this specific model and this metaphor in Concordia? So the way we can formalize it is that answers to these questions are, we will call them self-perception, situation perception, and person by situation. This is established terminology. The current state of these answers to these questions is Z. That's the current working memory of the agent, these answers. Given that, the agent generates a certain action, which then goes into the game master, produces an observation which gets added to the memory of the agent. And then, given that, we can update the state of the agent. The answers might change as we go along. The situation can change. What kind of person do you seem to be can change. It also can just change throughout the context, not necessarily there's some sort of character changing event. And so this is kind of a living process rather than a static characteristic. But this doesn't have to be these specific questions. It could be other questions. It could be, for example, something like, what is the relevant knowledge that I possess? What are my options? What is the rational thing to do? And so on. And they could be chained. There could be any structure. But all these questions, they're sort of addressed to the past experience. They're addressed to the memory. And the answers then constitute a context of activity. So we can, and then this is how kind of, if you want to have an LLM view on this, like the final prompt that determines the activity is like so. There is observation, which is just another kind of component. There are answers to these questions. There's a clock, and there's a call to action, which is like, what would Alice do in the next 20 minutes, right? And in the parlance of the Concordia library, we can think about all of these elements here as components. The components together comprise the context of activity for the action to be sampled. And there are some components that are already supplied. There's a lot of components that are already supplied with the library. Many of them you probably wouldn't want to edit much. For example, observation, you can just take it in and stick it in. And we will talk about how sort of these components work. And again, like clock, for example, it's just there. So like, yes, this is like the more schematic overview. So there are some components. There's a special component memory. They comprise the working memory together with the LLM and the call to action. They produce action. And this is kind of, you can think about this as the action component. I really recommend you check out this tutorial, agent component tutorial, if you haven't seen it yet. It explains that in detail. I'm not going to stop on this. This is just to ground. Like, if you have questions about more details, look at that. And it's important that turtles are all the way down. Components themselves look very much like the agent looks, because they also have a state. They also have other components they can depend on and retrieve from. And there is some sort of an LLM call in the middle that, given state of all the components and a certain question or some sort of prompt, it generates a new state. So this is where this kind of, what kind of person is Alice, going to go here. And this is going to be some sort of formatting of memories, and then there will be a state. Alice is person that is such and so and so. They don't have to work this way. You can implement anything that complies with the API. So, question of recent memories is the class in the library that implements exactly that process. Let's get some memories out. Let's ask them a question. Let's record the answer and present it to the agent's context of activity. So this is the main function there that creates the state of the agent. It's called make preact value. Again, I point you to the components tutorial to understand the details of that. But essentially, what it does, it gets the memories over here, scores them by recency. It asks the question. It throws the observations, the time, and then it asks, gets the components it depends on, asks the question, records the results as the prefix, and potentially it can also record the result into memory. So it's like, for example, Alice might, every time the component of who am I kind of updates itself, what kind of person is Alice updates itself, it can write into memory like self-reflection, Alice is so-and-so. So yeah, this is, so if you want to make a component, this is an abstract component that you supply questions and the component that would be a specific one that we would then use, and which one we will be writing today, would look like this. It's it inherits from this component, and then it just fixes some of the parameters. For example, question: what would a person like agent name? And this will be replaced internally, the special symbol, by the actual name of an agent in the situation. Do it like this, then there's answer prefix, which is simply that any answer to this question will have to start with this. And then, yes, we will add to memory with intent reflection tag. Okay, so actually, let's now go to the Colab. So I will start by switching to share this tab with a clean tab. We're first going to go to GitHub, Concordia. We're going to go examples, tutorials. Highly recommend agent components tutorials to everyone. Going to go agent development. I'm going to click open in Colab. And voila, here we are. And the first thing I will do is I will disable click this flag, disable language model. So what happens then is that we replace the language model with a dummy language model that just outputs nothing. So we can run and debug very fast, not spend any API queries. And we can just see that everything works. Then I go runtime, run all. Yeah, fine. So while it does all the installs and stuff like that, I will quickly walk you through what the Colab looks like. So there's obviously some imports. This is an important part. Here we can set which environment this agent will run on. So the script goes all the way from, we're going to take an environment, we're going to make an agent, put them together, run them, get the HTML with a transcript and the scores. So this is the environment. We can even, for example, change it for another one. Or maybe we just leave this one for now. This is the language model we want. If you want to, you might need to set an environmental variable for the API key. Right now, we disabled language model, so it doesn't matter at all. This is just imports. Okay, here we come. This will be where the question classes are defined. We will talk about them, obviously, in details. This is the place where they're kind of put together. That, like, if there's our class definitions here, this is a function that creates object of these classes. And then this is where we build the whole agent by putting together the components created here and a few kind of standard components like observation, summary of observations, recalled memories, overarching goal, and so on. There are a few pre-made factories like that. If you take a look in the agent factory folder in the Concordia, you will find several of them, but this is one. This is an agent factory. So actually, in the meantime, the script has ran. So since it's an empty LLM, you can see that there's a lot of nothing being produced. But here you can see that agents were talking to each other, and then they got some scores. They were recording, trying to find out which pub to go to together. And then the HTML got generated, where we can see different points in time what has happened. So what we can do here, every entry is an event that happened. The justice was, for example, that was her turn.
And right now it's all empty strings.
It's all empty strings. Yeah. Well, I will show. Actually, I have a pre-computed one which I can show it. But importantly, we can see all the components over here. So there are role-playing instructions. This is a constant component. There's like self-perception, which is given the above what kind of person is justice. The components that did produce some output are the memory ones because they don't depend on LLMs. And there's not justices, but there's nothing to see there. I will show you the actual.
It's because we set disable language model. That's why it's
yes. Yeah. So, for example, the way it would have looked if we had a language model on, it would be something like this. So this is Blair saying, "Has anyone been to Princess of Wales?" And the way he arrived to that was through this we can look in the act component. You can see that was the sort of the final prompt in the final question, given the above, what is Blair likely to say next? Because the conversation, that was the call to action. And there are all these, what kind of person is Blair? Blair is a sociable, enthusiastic person. What kind of situation Blair is? There's currently exploring the streets of Shoreditch with his friends. And then we can look at each component specifically.
Sometimes it says, what would you say next? Sometimes it says, what do you want to do next? It depends on the context.
So this is, for example, how component itself, situation perception, was constructed. There were some observations, and then there was a question given the statement about what kind of situations Blair in right now. So let's.
If I were to build, sorry, Sasha. So if I were to build my component in the section above in the collab, it would show up here in this HTML, and that's how I would see it. Would just insert as a new component on top. Am I allowed to delete old components, or is that generally not a good idea?
It's so I wouldn't delete observations. I wouldn't delete summary of observations. I wouldn't delete the clock.
Or the instructions.
All the instructions, but you might want to edit the instructions, or you might want to, again, you can also tweak observations. For example, you can retrieve more or less, but I wouldn't delete them. So no.
As a follow-up, I think, to that question, so are there any components that we, as a designer, I would not want to tweak or edit? For example, you showed earlier that there is an architecture plus memories. So memories are dispositions and previous things. Like, would there be an interplay between them where I design an architecture that somehow tweaks those memories? Is that something that can be done or should be done?
I think you can do whatever you want. Everything is possible in the system.
So, for example,
collab is kind of a tutorial for one specific way of configuring things, but you could configure things in any way.
But I think generally I would leave the memories maybe as they are, unless you really have a great idea how to make it better. Similarly, like observation components, they're probably just not the first thing to try to modify. But again, why not if you understand what's going on? Yeah. Okay.
I can imagine that being a story. Someone might make like a salience model or something.
Yeah, exactly.
Observe and what to remember or whatever. So lots of things you could do.
So let's look at how one of these components. So I have here 3 components: question 1, question 2, question 3. And right now they're configured exactly in that way that we talked about the 3 questions, like given above, what kind of person is agent? Then there's what kind of situation there, and what would a person like them do in a situation like this. So here I kind of, using the collab functionality, I turned them into forms. So we have the main controls sort of being exposed. It is the question, we can look at it's the question itself, the answer prefix, whether to add to memory with which tag. For example, we could, rather than what kind of person is the agent, what kind of question would we ask? Anyone has any ideas? It could be something even funny, or what would be the?
Is this the pub problem?
Well, it could be a pub problem. Could be.
We want it to be generic for any problem, right? So I don't know. How do people make decisions? They say, what
would Isaac Newton do?
Yeah, let's try it.
No, it's actually maybe something related to the agent.
What did my mother tell me, or something? Yeah. Yeah, what would agent name's mother say? Yeah. Yeah. Yeah.
And we can call it maternal reflection.
Nice.
And then we can, we'll go through the other questions, but now to make sure that it is correctly represented, let's quickly look how the object is actually getting made. Because what happens here in this function, sorry, sorry, this one above. Yes, make question components. The question one will be the answer to it will be represented with a label. So the answer would be like, Alice's mother would do so and so, and there is a prefix that it would surface itself in the context of action. And here it's the old one, which is question, what kind of person is agent so, and answer so. So rather than that, we can be question, what would father do? All right. So this is important. If you change something here, make sure it's going to have a correct label over here. Maybe I can even make that a parameter later. Okay, good. Now we can have a question two, which is given this, right now it's given the statement of what kind of situation is right now, or like here it could be from astrological point of view, what should be situation?
Oh, the situation is this.
Is this
Nice.
Okay, this is fine. And maybe the third, we actually just kick it. You know, we just go boom, boom, done. So the first thing we do now, and oh yeah, and it was like we also copy paste here the label for the astrological reflection. And we go somewhere. So first, we will run without any language model, simply to check that everything's correct, everything runs. And I think what most importantly that we just can also look into the resulting HTML and see that all the questions are there in the right formatting. And we didn't forget anything, that it kind of, although it's empty strings, they still kind of look in the right order, and all the labels are there, and all the components are there. So it seems to be running, which is nice.
While this is running, you mentioned above environment selection. Where would I find those environments, and what kind of environment should I expect?
Okay, so let's open the GitHub. So I'm on GitHub. I go to examples, modular, environment, and here are a few. So the default in this collab is pub coordination. So this is a game where friends are trying to decide which pub to go to watch a game. They have a first a space to have a conversation about it in some social circumstances, like they meet in the city and go for a walk or meet for a bike ride, and they have some time to talk about it, although they know that it's supplied from memories, that there's going to be a game later and they want to decide. And they each have a preference for different pub, but they would also enjoy it more the more all their friends would come together. So this is you might recognize Bauhaus-Stravinsky flavor here. Also, sometimes a pub can be closed and only one player knows about it, so it's their job to communicate to everyone else. So, and this is the kind of games you should expect. All you need to put in is just the name of the spy file. So everything you see here, forbidden fruit, haggling, labor, collective action, London is a like all of these things, you just put in the name and it will run on it. So I imagine we are done. There we go. So yes, Rakshit.
So going back to this Colab, so you showed currently like one building of like one component which is in the form of questions. So if, let's say, if I want to add like a new component, do I need to always frame it as some sort of questions that is required to be given to the language model, or I can do it in a different format?
You can do it in a different way. So if you look in the components tutorial, it explains how you can build components from ground up. And there it could, like, you can run Python code, you can have multiple queries, like you can have complex chain of thought if you want. You can call tools potentially if you know how to and you know where to get them, like a calculator or whatnot. So you can do those things. It is just that this is the demo of a particular way which we surfaced, which we find quite expressive, and it's a good place to start. There's also another which is query of associated memories, the class is called, and there it's a little bit different. Rather than if here we just retrieve recent memories, there we retrieve memories with a query, and then we ask question of them, and we have several queries, and then I summarize it together. So for example, like somatic state can be implemented like that, where we ask of like the level of thirst, the level of fatigue, the level of hunger, and then we ask like what is the physical state, so and so on. So yeah, anyway, here we have the output. So we can take a look at the act component, see what is there, and we can see that there's question, what would Finley's mother do? Finley's mother would. So okay, we have an empty model, so it's all fine. It seems to be doing the right thing. There's instead of apostrophe, I just have a slash here, so I could go up and and to correct. So we can just make sure that, like, what I'm looking for is that the questions asked correctly, they're all here. Like we can look at them, so we can see that this is the astrological reflection. We can see that it's still, the component name is still situation perception. That's because it didn't change the name of the class, because I didn't bother with that. It's fine. We could change that, go and change that for keeping things clean. And we can see that it sort of worked out. It asked the question, what is the astrological point of view? Oh yeah, so question from an astrological point of view, what station is this? So everything seems fine. So what I could do now, I could go and put in the API key and run the Colab and then get the real results. So just for the matter of speed, I will open the Colab where there's already stuff. So that's what we looked at it before. So it would look like something like that. There will be real text here. Sort of the real answers to questions. This is the situation perception, and you can see that's what it does. So, and then the other thing you look at, apart from this script, you can also look at the scores. So they are here. So you can see that there's a text description of who went to which pub. And there are scores. Scores are not directly communicated to the agents, they're communicated just to the agent developers. Maybe sometimes where in some environments it's pretty clear, like the rewards are money and agents know how much money they have. But here, for example, we can see that sort of those that went to Crooked Billet ended up getting a little bit more reward because there were a little bit more of them. And maybe it aligned with some preference. And we see Justice got really low score, though, although he was the one who went to the Crooked Bill because probably it wasn't the pub he preferred. So his preference was quite low for it. But yeah.
How is Justice a name? Justice is a name?
I don't know why Justice. Like, let's keep the conversation. Why not? Everything's a name. Okay. So yeah, that was it. Is there any other questions that come up?
Yes, so you said that I could select from a number of different APIs for training different models. How would that impact this? And can I fine-tune my own model to get a better performance out of this?
So
that's more of a question of the APIs.
Yes.
Make available, right? These
So what we have here, we already have a bunch that you could wire in. Of the kind of publicly available
That PyTorch Gemma one, right?
Yes,
just in PyTorch, right? So you could fine tune that if you want, and that would work.
Yes, it's a bring your own LLM kind of situation. So the contest is more sort of prompt engineering, I guess, oriented, but you could try to fine tune a model. And I mean, the point is though that we are going to be evaluating everything on the model that we have. So you can do it for fun, you can do it for research, but it will not win you points in the contest.
Awesome, thank you.
So to circle back to the previous question, you mentioned that you could build any type of specialized components, but I assume that if you use some kind of external tools or something like that, then you would it would not be possible on your end to directly support that, and we will need to find a way to submit.
Yeah, so
something like that.
So yeah, I guess you definitely can't query Google, but I wonder if something like a Python calculator can try to implement a Python calculator or something like that in there, but I don't think you will need it. So I would also just summarize. If there are no more questions, I want to summarize? Or there's something? Yeah. So summarize setup. You open the Colab, you paste an API case, you disable the LLM for debugging so that you don't waste API calls. Play around with questions, make sure they look good. Play around with component. Oh, yeah, there's also, actually, that's what I forgot to say. So good thing that it popped up. Let me quickly tell you something. So another thing that components can do is depend on each other. So here in the component section here, you can say you can make question 3 depend on question 1 and question 2. For that, you supply a dictionary where the key is the name of the class of that component, and the value is its label. So what will be put in front of its state when it is being used will be concatenated to the state. So remember, it's by class name. So question 1, question 2. That's why question 1 is here. So you can play with that structure as well. So for example, so question 2 here depends on observation. I know that that's the name of the observation component, observation summary. So you can add it, you can play around with that structure. So for example, the question 2. Yes, Rakshit.
Yeah, maybe once you finish this, like, where is the place where you combine all the components to like build a final agent? Like, is there a place where you put them together?
Yes, this is done here in the build agent. It's all in the Colab itself, so you can find it. Actually, can I just like not have this maybe? Yeah. So this is the build agent. This is the factory of the agent that you could use, you could edit. So here you can see that all the components are being made, the observation, summary of observation, it's all the same pattern. You make a label, you create the object of a class that usually needs a clock, maybe some extra parameters, the measurement channel for logging, and then you put them together. And these 3 questions came from calling this function, because this function just above, I just for clarity moved it up there. This is the one that creates components. And yeah, so if you want, there are several examples of agent factories like this. Maybe I quickly show where they are. So if you look in Concordia factory agent, you will see several of them. For example, let's look at this one. And here you can also see that there's that's a familiar build agent class. Again, building very similar to what we had. But for example, here there is also a plan component, something that we didn't have in the other class, but it's a component for making plans. You could, for example, copy paste things from here into your agent. And there's a few of them over here. You can take a look. Okay, good thing that summary pointed me to the last few things. So yeah, you can play around with components independent structure. You can add new components like take the plan, or you can look at the library of components that are there. You can write your own. You can write it right in the Colab. You don't have to necessarily bother with putting something into the code that you run. You investigate the HTML and scores, just see everything looks good. Repeat as many times as you want. When you feel like everything's like the structure of components and all the questions is kind of what you want, you turn on the LLM and you get a real run, and you get the outputs, and you try to improve. You compare. HTMLs are also saved, so you can take a look at them and keep a record. And yeah. All right. Awesome. Cool. There we are.
Thank you so much.
Thank you.